Okay, let's look at some more examples of the law of syllogisms. Remember, in order for the law of syllogism to be able to have a conclusion drawn, we have to be able to see that the conclusion of the first statement, or of one of the statements, becomes the hypothesis of the other statement. And if it does, then we can connect the hypothesis of the first statement to the conclusion of the last statement. Okay, so let's look at this first example. If a quadrilateral is a square, then it contains 4 right angles. If a quadrilateral contains 4 right angles, then it is a rectangle. So you can see clearly that the blues match. The conclusion of the first became the hypothesis of the second. So we can immediately connect the first hypothesis with the last conclusion. So I'm going to be able to state for my conclusion, I'm going to be able to state if a quadrilateral is a square, then it is a rectangle. Now you may or may not understand that, but a rectangle, the only definition of a rectangle is a quadrilateral with 4 right angles. So that also classifies as a square, because a square also has 4 right angles. So a square is a type of rectangle. Okay, so that's why that statement makes sense. If a quadrilateral is a square, then it is also a rectangle because it fits the definition of a rectangle. Okay, all right, let's look at the next example. If a number ends in 6, then it is divisible by 2. If a number ends in 4, then it is divisible by 2. Look at the blue. Look at where they're located. In the first statement, it is the conclusion, and it's also the conclusion in the second statement. I cannot draw a conclusion from this because one thing doesn't lead to another. It doesn't say if a number ends in 6, then it is divisible by 2. If a number is divisible by 2, then it something else. It doesn't say that. It gives me the same conclusion twice. So it is not possible for us to make any conclusion based upon those two statements because they both have the same conclusion. If they have the same conclusion, that does me no good. I have to have the conclusion of one become the hypothesis of the other. Okay, look at the next one. If x equals a positive number, then x squared equals a positive number as well. Now look at the second statement. If x equals a negative number, then x squared equals a positive number also. This is like the one above it. Neither one of these are capable of being turned into a conclusion because they have the same conclusion. This one never leads to the other one. So again, I'm going to write not possible. And rather than writing all this out up here again, I'll just write same conclusion. They have the same conclusion. That doesn't help me. Okay, look at the next one. If a triangle is an equilateral triangle, then it has 3 congruent sides. If a triangle has 3 congruent sides, then it is an acute triangle. So see, look, the conclusion of one is the hypothesis of the other. So it's leading me from one thing to another. If a triangle is an equilateral triangle, then it has 3 congruent sides. If it has 3 congruent sides, then it is also an acute triangle. So I can immediately make the change, and I can take the first statement, the hypothesis. If a triangle is an equilateral triangle, then it is an acute triangle. All right, and then the last one, sometimes the statements are out of order, but they still can lead to a conclusion if the conclusion of one statement is the hypothesis of the other. So this one I wrote, you might have to reorder. Watch this. If two planes intersect, then they intersect in a line. If two planes are not parallel, then they intersect. You should be able to see that this one really should go first, and this one should really go second. So it should sound like this. If two planes are not parallel, then they intersect. If two planes intersect, then they intersect in a line. So if I read them in the correct order, you should be able to see that you can draw a conclusion here. They're just in a different order. If two planes are not parallel, then they intersect in a line. So again, they should be reversed, and sometimes that happens. Sometimes you're going to have to reorder the statements in order to see that the conclusion of one becomes the hypothesis of the other. Okay? So it gives you some more examples of the law of syllogism, and in just a few minutes in the next video we are going to combine now the law of detachment and the law of syllogism and make two conclusions based upon each law.